Good morning, teacher, or good night, or good afternoon. My name is Rafael Domingo Lusanilla, and this is my presentation. The topic is taxonomic responsible of bacterial and fungal population to biofertilizers applied to soil or substrate in greenhouse or grown cucumber. Um, the introduction. Cucumber is an important vegetable crop that is widely grown and consumed throughout the world. Almost QMHE were used worldwide, produced around 75 meter of cucumber or tons cucumber in uh, 80, 2018. In China is the main producing countries. Uh, the soil-borne disease such as Fusarium with rogue nematodes of bacteria, specifically the RKN and melody gain SPP, PP significantly decrease cucumber yield and quality by accumulating in the same and soil and use the produced crops every year. Those pathogens will leave uncontrolled can effects for these populations, large production areas and thirdly, significant limited cucumber production, quality is and expectation of the industry. The soil plays in the indispensable role in the ground and development of plants. Uh, how the cucumber in the image. This is the fungi, um, uh, and they're crucial for the decomposition and transformation of organic matter in the soil, include the degradation of the animal and plant residues. For this case, the decomposition of humus and the recycling and utilization of nutrients and having the degradation and purification of organic pollutants. Uh, the excessive dependence of um, chemical fertilizers to increase crop yield and in industrial scale agriculture. This agricultural production is damaged and the environment and the ecosystem, etc. Uh, affect the human health. The chemical fertilizers can replace biofertilizers, which contain beneficial microorganisms that can enhance crop production without harms to human health. With the fungi and bacteria. Next, the nutrients and beneficial microflora contained in pure fertilizers the, the fungi and bacteria have led to improved crop production and quality. They have been reported to reduce ecological degradation and suppress airborne disease. Beneficial microorganisms such as Trichoderma harsarium and Bacillus subtilis for these emissions, these microorganisms. Uh, this is in the biofertilizers promoted colonization by other microbes, inhibit pathogens, and induce plant system resistance to disease. Trichoderma. This is a commercially available biocontrol fungal agent applicable to soil to control soil-borne pathogens and improve crop growth. Trichoderma exhibit several useful properties, including microparasitism, absorption of nutrients, good colonization ability, and production of the antibiotic substance and promotion of plant systems resistance to pathogens. Trichoderma stimulate the yield and promoted the establishments of communities of beneficial soil microflora. There be improve soil microbial activity and enhance soil fertility the soil fertility. And the bacillus bacterium is very common bacterium that significantly promotes plant growth and the corporate yield. Bacillus stimulates synthesis of auxin in plants and formed and the spores and different biological, biological activity components important for the biocontrol of plant of pathogens. The materials and methods this article. Localization of greenhouse. In 2001, a large greenhouse in the Xiaoping district of Beijing in China was selected for the research trails. Cucumbers had been continually produced in greenhouse since 2016. The main components of the substrat included PET, cocoa bran, fertile vermicule, and residual host. The image, this is the localization real localization in China for GPS. The article have these coordinates. Preparation of biofertilizers. So your preparation of trichoderma spore suspension, the thesis fungi afrohisam. This is the Trichoderma afrohiharsinau strain 267 had been identified and stored in our laboratory since 2019. This species was cultured in PDA for 5 days, and the spore suspension was washed with sterilized and distilled water before being filtered through 4-layer gauze. The concentration of the first suspension was adjusted to 1 plus minus dot 0.5 for 10 to 7 spores intermediate using a hemocitobacter. Hemocitobacter. Field experimental design. The 12 treatments were diluted with deionized water and stabilizers in blood following a random block design. The biofertilizers were applied 2, 3, 4, or 4 weeks after the cucumber seedlings were planted in the greenhouse. Cucumber roots were treated with 50 milliliters for plant of trichoderma spore suspension. The concentration I mentioned anteriorly. For further commercial biofertilizers, treatments were applied to cucumber for rootstock. This is the compresses, 72 milliliters for Bacillus subtilis, biofertilizer diluted for 400 times, treatment 2BS, and 36 milliliters for Bacillus subtilis, and 20 grams the thermodactyl harsanium biofertilizers diluted for 400 times, treatment 3 pH. This is the initiation, the BS and BH, depend the type, the experiment, and 72 milliliters of compound microbial fertilizer diluted for 400 times, treatment 4 M, and 40 grams of the thermo, thermodactyl harsarium biofertilizer diluted for 400 times, treatment 5 HC. Sixth treatment was the control consists of deionized water added to soil and substrate. This is the treatment 6 CK. Each treatment is special was replicated 3 times one with 100 cucumber seedling in each replicate. Methods of soil and substrate psychochemicals properties. A continuous flow analytical system, Alliance Instrument de France, was uses the quantify ammonium nitrogen and nitrate nitrogen concentration in each soil sample. The available phosphorus was determined according to the method described by Olsen et al. Available potassium was determined using AFP 640 flame photometer, Shanghai Instrument Group inside of the China. The organic matter OM contained the fungi or bacteria, content bacterial content was quantified according to the oxidation reduction method described by Schneider et al. Cucumber grow, gel, and soil-borne pathogens. The cucumber head and stem diameter were measured every 7 days from the day the seedlings were transplanted. The total merkel yield of cucumber from each treatment was recorded in kilograms. Each harvest selected medium methods were used to insult columns of Fusarium HPP and Photophthora HPP in the soil and to calculate their abundance following the method described by Komada and Masago, respectively. Extraction of soil and substrate DNA and PCR amplification. The method is I have 10 grams of the cellulose or substrat were homogenized in 40 milliliters of sterile water. The homogeneity was then filtered through two layers of sterile medical gauze. The gauze was raised several times with sterile water to recover residual microorganisms. The filtrate was centrifugated at the 10,000 to 12,000 G gravity at 4 cent centigrades grades for 15 minutes. The total source and substrate DNA was extracted from H. Dot Q 25 grams soil and substrate sample following to producers described in the DNS Power Soil Pro kit. This is the of China. The extracted DNA was planted of the 1% agar scale for electrophoresis, and the DNA concentration measured using a nanodrop ND 100 1000 UV spectrophotometer thermofisher scientific. This is from USA. High throughput sequencing. The method this is perfect PCR products were sequenced at major biofarms technology. This is in China, and the microbial analysis were conducted is using the MySQL PA 300 sequences platform. The raw sequence were processed using the motor software. Uh, in the article, this had the link for loadout. A sequence with less than um, 50 with ambiguous bases on the thousand those with an average mass less than um, two 30 where the model be flash. This is the article or the mentor. Chemio software version 1.9.1 was used to calculate the riches in the flora and diversity of the flora. The statistical analysis, these methods, the for the calculate the efficacy of treatments on the soil-borne pathogens was calculated using this formula where A is the relative efficacy on soil-borne pathogens in percent and A H no H0 is the colony number of the soil-borne pathogens in the control group, and H1 is the colony number of soil-borne pathogens in the treatment group. The results: growth of cucumber plants in response to the different biofertilizers. In the soil, there was no significant difference in cucumber growth before microfertilizers was applied. However, some microbial fertilizers significantly increase cucumber weight height and stem diameter, the height and diameter when they were applied within for 4 weeks from where the seedlings were planted. Uh, this is graphics, and this not more difference AB. But the next growth of the cucumber plants uh, in the soil, and the second with HHC and HMF increased plants 8 be 1 11 dot 2 and 9.5% respective, and the third week is 267 and HBS and HBH and HM and HSHC increases plant height be 12 30.8 15 and 30.5 and 26.9% respectively. This is in this uh, graphic here. Uh, Equal soil in the 4 and 5 weeks. Some tractors significantly increase cucumber height. In the second and third weeks is X267 significantly increase stem diameter be 21.2 and 16.8% with this graphic. Equal soil over the second 5 weeks, some microbial fertilizers treatment decrease cucumber height and stem diameter. This is for all treatments for next after 5 weeks. This the egg and the stem diameter down with seen in the graphic. In the graphic. And the substrat, there were no significant difference in the cucumber growth before microfertilizer and was applied. But in US 267 and USHC significant increase cucumber height be the 39.8 and 75.4% and 56.1 and to 86.1% respectively. US 267 and USM and UHC significantly increase the stem diameter be the 76.8 to 108.9%, and the and the and the 80 100.4 to 122.4% respectively, you can see in the image. Over the subsequent 5 weeks, US 267, USM, and USHC treatments continued to significantly increase cucumber height and stem diameter. This is equal the soil. Then the after 5 weeks, the height and the stem diameter down, for you're seeing in the graphics. Okay, change in the taxonomic composition of the soil-borne fungal pathogens. The soil biofertilizers application significantly reduces the taxonomy composition of soil-borne fungal pathogens at different times during the cucumber growth period. Fusarium SPP were significantly reduced of the time of the 63.8% reduction of the time. After the three application of T-Harsalium, which was during the early period ground. Down, this is the table, more specific, these dates. Of the substrat, the fusarium was significantly reduced. The 87.5% reduction of the time after the third application of USBS, which was during the early period of growth. The Phytophthora HP was significantly reduced the 81.6% of the time. B strain 267, Fusarium and Phytophthora were significantly reduced. The US 278 and USBS and USHEC at the time the cucumber were uprooted during the latter period of growth. Age treatment had significantly reduced Fusarium HP by more than 60%. Change in cucumber gel. Some treatments significantly increase cucumber gel after microbial fertilizer application to plants growth in soil. ACE is 267, HBS, ASM, and HHC significantly increase cucumber gel. ACE 267 and HHC significantly increased cucumber gel by 28.8 and 27.7% respectively. This is the image for Corvola. The diversity analysis of bacteria, a total of 1 million uh, seven seven thousand nine 9,000 and 962 value reads were obtained from uh, uh, 16S RNA amplification sequencing after timing. The average length of the application was uh, was 428 BP. Uh, the number of the value sequences detected for each soil simply exceeded uh, uh, 40,000. The sparse curve was fat, which indicate that the genetic data were sufficient for a reasonable estimate of the total taxonomic composition. The analysis the microbial community diverse index in solely responsory to the H biofertilizers treatments showed that the OTO diversity and richness were like the control. In the early stage of the cucumber growth period and the after the three application of biofertilizer and the late stage of the cucumber growth period when the cucumber were uprooted, where there were significant changes observed in the soil and substrate alpha diversity in the microbial community. The bacterial hierarchical cluster analysis at the OTO level. The results, the hierarchical cluster analysis showed that different treatments had different effects on the taxonomic structure of microbes in the soil of substrate at different stages of cucumbers plants growth. And this is the the image of the analysis, ANOVA analysis for the different treatments and different effects in the cucumber plants uh, con, with the OTO level. The change in the fungal general dominance, a total of the 1,080,000 800 59,284 value reads were obtained from ETS RNA amplification sequencing after quality training. The average length in the amplification was 221 BP. BP, this is the par, the the other one. The number of the value sequence detect for each soil sample exceeded the curve the exceeded the 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 40,000 the sparse curve indicated that the genetic data were insufficient. Discussions. Was observed that microbial fertilizers applied to soil or substrate in a greenhouse increase cucumber quality, yield, and the abundance of bacterial and fungal genera involved in the control of soil-borne pathogens. We observe that some the biofertilizers that we test increases the growth of cucumbers grow in soil or substrate. Within 10 weeks of applied subtrataments such as ACE267 and HHC significantly increase cucumber plant height and stem diameter. And US 267 USM and USHS significantly increase the stem diameter and plant height of substrate growth cucumbers. All findings were consistent with the results of cell vacuumar article, where it's observed that the relative abundance of microflora or microbial, pedomicrobium, and helium increased significantly. Microvirga SPP are thermal tolerant bacteria. They are metabolically versatile and widely distributed in nature. And in addition, microvirga is also reported become environmental remediation the soil in a special as it can remove residual contaminants uh, and soil and the water, and especially in soil. Pedomicrobium is a ubiquitous occurring heptal bulging organisms that can adhere to surface and form biofilms and different habitats. Heliagum campus produce a type antifungal metabolite which inhibits the growth of fungi. Um, this is finished. This is my resume of my article. Uh, Thank you very much. See you, teacher.